Assalamu alaikum wa rahmatullahi wa barakatuh. In this video, we are going to talk about the third fundamental theorem of integral, or we call it the mean value theorem or the average value theorem. Let us recall the mean value theorem or the average value theorem of derivative. If f is a continuous on a closed interval and differentiable on open interval, so there is a value c between a and b. Somewhere between a and b, this value satisfies that the slope of tangent line is equal to the slope of secant line between the 2 points A and B. Now, all what we do here to get the mean value theorem of integration is only to take the integral for both sides. So this will be exactly f of c, and the other one will be, we write here capital F minus capital A. We mean it is the integration of f of x from A to B, the definite integral from A to B. That means f of c equals a, the integration from a to b of the function f of x over b minus a. And sometimes we write 1 over b minus a multiplied by the integration. And f of c, we call it the average value theorem. For that reason, sometimes we write f of average. So there are many applications for this theorem in physics and in real life. When we say the average velocity, the average temperature, and many information like that. There is another shape to write this theorem. When you just manipulate with the equation, we get this idea. So this is the average value of theorem, which is the integration or the definite integral multiplied by 1 over b minus a. And be careful, guys, there is a big difference between average rate of change and average value of function. Average rate of change, or the slope of secant, it is f of b minus f of a, but average value of function, it is the integration of the function over b minus a. Now let us take this example. Find the average value of the function sine x on interval 0 pi. We know that sine x is a continuous function and differentiable. So there is a value c between 0 and pi, somewhere between 0 and pi. And this value of c satisfies that f of c equals 1 over pi minus 0 multiplied by the integration from 0 to pi of the function sine x. So all what we need to find the integration of sine x, which is, we know it is negative cosine. So then we replace, or we apply the fundamental theorem 1, which is f of up minus f of down. So we get 2 over pi. That means f average equals 2 over pi. Now, there are some, as I said, as I mentioned before, there are some application. The average speed, the average temperature is the same idea, just we need to apply the formula of the average value theorem. Let us take this example. Suppose the population of a city is given by this function. Okay, and from 19,000, which is the year 0, now what's the average population? We have the population function. We need the average population between 1950 to 1960. It means from t equals 50 to t equals 60. From 50 to 60. So the average population, you usually say it is integration, or sorry, 1 over b minus a, here 60 minus 50 multiplied by the integration from 50 to 60 of the function p of t. And we need only to find the integration either by calculator or by normal integration techniques. And the normal integration techniques here, the 3,500, we can take it outside of the integration. And we know the integration of e to the power 0 of e to the power 0.03t, it is 1 over 0.03t, sorry, by the exponential itself. Then, as usual, we should replace up and down. We should replace the function up and down by applying the fundamental theorem part. Let us take more advanced examples. Here we have this example. The height of a jump of Bush Puppy is modeled by this function, and here clearly the height is given to us, and we need to find the average speed. If I need to find the average speed, I should have the function of speed. We don't have a function of speed, so we need first to find the function of speed, which we know it depends on the velocity, the absolute value of velocity. So also we don't have the function of velocity. So we need to find the function of velocity. And the function of velocity, as we know, is the derivative of the function of the position function h of t. But still, h of t is not given to us as a function. It has some missing information, which is the initial velocity and half of the gravity. So we need first to design, and we don't forget that the average function, it is 1 over b minus a for f of x. So all what we need here, we need to find the velocity function. And we know the velocity function depends on the position function. So first, let us develop the position function. I need to replace the initial velocity by 600 that's given to us in the question. And I know the gravity is 980 centimeter per second square. So we developed, or we created, the position function. Then I find the derivative, and the derivative here, it's clearly easy. The derivative of 100t, it's 100, and the derivative of 490 by 2t squared just will be 2 by 490. Then the speed is the average, sorry, the speed is the absolute value of the position function. So this is the speed or function, and 600 minus 980t is the velocity function. So now we have the average speed. But the problem, where is the interval? What's A? What's B? A and B here are the beginning and the end of jump. It means the beginning when the jump starts, or the Bush Puppy starts, and when it ends. So that means we need to take the height function and make it equal to 0. When I solve this equation, I get t equals 0, which is at time equals 0. So this is the beginning. And after solving this equation by calculator, mode 5, 3, whatever, so we get this time. So we have 2 times. So this is A, this is B. So we can say now the average speed, it's 1 over b minus 0, integration from 0 to 60 over 49, absolute value of this. Now, since we have absolute value, either to rewrite the absolute value into 2 functions, or we can remove it, as we know there is no intersection point, or use calculator.